Well, good evening. Thank you for coming out at 7 o'clock in the evening to hear another presentation. I'm sure you've been busy all day doing these kinds of things and listening to lots of us speak. So I really appreciate that you're coming to this late session. I'm Thomas Blood. I'm an enterprise strategist. I work in the Europe, Middle East, and Africa, and I travel extensively meeting with executives from large enterprises throughout EMEA. And we talk about digital transformation in the cloud, cloud adoption, migration, cultural change, org change, and product. So today I want to share with you some of the insights that we've gleaned and some of the best practices that we've seen in product development, both in terms of the overarching best practices, but also in terms of what does it mean specifically to cloud with AWS. But before I do that, I'm really interested to see what brings you this evening. And so by show of hand, I'll just go through each one of these. You're trying to introduce new ways of thinking about product development in the organization, and you're running into the corporate antibodies and resistance. Any takers? A couple, okay. All right. Second one would be you're interested in, what's an overview of the best practices in product development? Okay. All right. Looks like there's some overlap here. The third one is you're looking at how can I improve current practices in your organization or that of your customers and clients. Okay, a couple. And then the fourth one is about innovation. This is something you're looking at, how can I innovate in product development? Any takers for that? A couple. All right. Okay, good. So hopefully the presentation aligns with what you need to hear. If not, well, sorry. So before we get started, I'd like to talk about the baseline. What are the basics of product development? So I'm going to do a quick tour of what we think of as modern product development practices. And first I'm going to look at the product development processes and methodologies. The second one I'm going to look at is organizational flow. And the reason we're looking at flow is companies and organizations have realized increasingly that they have to be faster and more agile, get to market a lot faster. And so by implementing some of these methodologies and pursuing this idea of our organizational flow, you can vastly accelerate your time to market and your agility and your ability to react to market forces. And then finally, we're going to take a look at how does this all relate to cloud and how does cloud enable product development further. So I submit that there are three different critical components to modern product development. The first one is how you figure out what work to do. And so one common framework for that is design thinking. The second one is, once you figure out what work to do, what's the right work to work on, how do you organize your team most effectively to get that work done? And I would submit that this is Agile, and Agile has been around for a long time, but increasingly we see enterprise customers are now adopting Agile after a long, long time of kind of not playing with it or experimenting with it, and now there's a massive surge forward into Agile. And the idea here, of course, is how do you break work down into small, digestible chunks so you can go faster? And then finally, when you're doing a lot of work and a lot of development and you're going really fast, how can you do it with a high level of confidence? How can you be sure that you can deploy things into production in a healthy state as quickly as possible? So customers I talk to, they are working on all of these, but sometimes they're doing it sort of in a disjointed way, right? So they're working on one or more of these methodologies and these ideas. But if they miss one of them, it becomes really difficult to achieve that organizational flow that they're after. So the successful enterprises we talk to are doing all three in an interlocking mechanism. They're interdependent, interrelated, and they leverage all three together as a way to create a software development factory, if you will. So let's start with design thinking. Design thinking is customer-centric. But customer-centric is one of those terms that's been floating around for years and decades. In all product meetings, all product managers always say that they're customer-centric. But the idea is that you want to get insight from your customers as early as possible. 10 years ago, organizations were struggling with, how do I get this feedback? How do I do this? And they created this methodology called design thinking. And really what design thinking is, it starts with the customer. It's putting the customer at the center and trying to understand what it is that they need to drive product development, to drive features. And the idea is you want to get to those features and ideas as early as possible, so that you're not spending a lot of time building something that might be heading in the wrong direction. You don't want to invest a lot of money up front and spend a lot of cycles developing something that later turns out not to be what the customer actually wants. So design thinking is meant to get to that answer a lot faster so that you know you're working on the right thing. So in design thinking, there's a large body of work already in both the academic world but also in the practical experience gleaned from customers and from practitioners all over. So when you think about this, you have to understand what it is that the customer actually needs. So what are the pain points? What are the problems that they're running into? What are the things that maybe your services and features don't currently provide to that customer? Trying to understand exactly what that is. And one way to figure that out is actually an older methodology that comes from Toyota. Probably going to butcher this term, but it's Genshi Genbutsu, which means go out and see. So the idea is go where the customer is, go to their habitat, their environment, and see them interact with the systems in real life. Because a lot of times when we build things, we do it designed by engineers for engineers, and we assume that we know what customers actually want. And one way to do this, because maybe you can't go out to your customer all the time, is actually bring the customer into your organization. To do interviews, to watch them perform, to watch them interact with your system. Once you've done that, then comes this idea of framing the actual problem, understanding and defining what that pain point is. And it's important to understand from the customer's perspective, where is this pain point? What is the problem that needs to be solved? A lot of times, and I am definitely guilty of this historically, we build a solution and then we go look for a problem. But we want to do it the other way around. We want to start with the customer, say what is the problem, and then drive to the correct solution. Once you understand the problem, you define it very clearly and understand exactly what that pain point is, then comes the ideation phase. And it's important to get lots and lots and lots of ideas and not to get stuck on one particular favorite idea, right? This is a phase where you're throwing out as many ideas as you possibly can that are creative and innovative and maybe outside the box. And then you experiment with those. Now this is an interesting part because developers and engineers, they get excited, right? And they want to build something right away. So you have an idea of how to solve a customer problem and pain point, and you want to get going. Resist the urge to do that. Because at this phase, you're just trying to get to a quick test, a quick, simple, frugal test to understand, is this proposed solution actually what the customer wants? Because otherwise, again, we'll spend time and cycles building something only later to realize that it's not what the customer actually needs. So when you think about product development, one of the key points is getting feedback back into the cycle as quickly as possible. And that's really what Agile is good at and good for, is to get as much feedback as you can back into the production loop. So you can constantly iterate and constantly revise what you're working on. There are many, many different agile frameworks out there, but they all have in common. They would try to learn from the customer, they learn from the experience, learn from the process. And by the way, you can get feedback directly from customers, but you can also get feedback from system metrics, from logging, from outcomes on the customer side, or directly from customers. So when you look at Scrum, the idea behind Scrum is that you're continuously grooming this backlog and you're continuously working on what's the next best feature to work on in the sprint, but you never change once you start inside that sprint what you're working on. You finish the sprint and then you go to the next backlog item. Whereas in extreme programming, you're actually doing something a little differently. You're trying to get customer feedback directly during each sprint. So you might actually have a customer or someone who represents the customer in that process, in that team. And Kanban is a different approach again, and the idea here is that you're finishing a piece of work in a sprint, and as soon as you've finished it, you can pull another piece of work. This is the work in progress idea. What's also very challenging for organizations when they go through this process of trying to adopt design thinking and agile is that traditionally for 20 or 30 years we've been trained to have a roadmap and a clear plan and very, very well-defined guidelines and requirements for each thing. And it's hard to change that after doing that for 20 years, right? And so when we go into Agile adoption, we need to do it. We need to rip the Band-Aid off, right? But we want to do it in a way that is a little less painful, a little kinder. And one way to do that is to create release maps. And release maps are essentially the next several weeks or several months of epics. Epics are these longer stories that are around products or features. And you string them together so that the teams have an understanding, where are we going? Because otherwise, they feel a little lost, or they can feel lost by the constant change that's happening in the sprints. Right? So this gives sort of a bridge in this process where organizations can take an easier road to go into the agile process. The second point here is having small teams. So if you think about traditional projects, we put together people from all over into a project. Maybe 50 people or 100 people could work on a project. It's really hard to maintain communication when you have that big of a team. So in a two-pizza team, you're trying to reduce the communication. You're trying to have a much smaller team that's working together. And I'll talk more about what we think about in terms of two-pizza teams a little bit later on. I have been in agile transformations a couple of times, and typically the teams don't get it right in the beginning, right? They struggle. They kind of get stuck. Things don't work. It's supposed to be shippable code at the end of each sprint, and often it isn't. And one way to fix that is to insist on having demos of working code. And you want to invite the executives into those demos. So it's not just the developers amongst themselves, although that'll work. But bringing in an executive into that demo is really helpful because A, the team then sees that it's important to the executive, right? They actually care about what's happening. And B, that feedback happens very immediately if it doesn't work, and the teams are frankly embarrassed. One of the other things that happens when you go down this agile development process path is the teams become a little fanatic, or they can be fanatic about agile, right? And they might say things like, no technical debt ever, cannot happen. We're only working on continuous improvement. Technical debt is no longer allowed, right? Or they might say that there is no more planning. No plans in Agile. We're just going to develop, and when work comes in and new features come in, we'll do them, and we don't need planning anymore. But that's a trap, right? This is not really true. You have to merge a discipline around it with the benefits that Agile gives you. And then finally, when you look at, you've understood the work that has to be done, you've chunked it out, you've brought feedback back into the team. Now the third leg of the stool is DevOps. And DevOps, in my mind, is rocket fuel, because you can guarantee repeatable processes for the teams to get software out into production. And you do this by automating everything that you can, and particularly the areas where there's a handoff. You know, you have, in traditional environments, we have these siloed handoffs. The various silos throw things over the wall. Whenever you throw something over the wall, the communication can break down. If you can automate that process, you reduce the source of error and confusion and frustration, and you streamline things, and it goes a lot faster. And when you're doing DevOps, you can actually set up guardrails that protect us from ourselves and have security-approved processes. You know, you can have processes that make sure that you're adhering to your internal security policy. And with these guardrails in place, the teams can go a lot faster without having to worry about the risk that's associated, because you've already automated the risk mitigation. When you combine these things, these DevOps principles, you're reducing the cycle times and you're getting things out into production a lot faster. And how fast? This is a study that was done by Puppet Labs after interviewing thousands of their customers over the last 5 years or so. And I think these are extremely compelling. A 5x lower change in failure rates. That's astonishing. Just think of all the outages you don't have to deal with anymore when you do that. But my favorite number is the 440 times faster from a commit to deploy process. Speed matters in companies. Getting to the market faster, getting things to your customers faster is really the differentiator today. The faster you can go, the faster you can get things out to your customers, the better off you are. And DevOps allows you to do that. And then you look at that last one, 44% more time spent on new features and code. That's an enormous benefit, because we've done a lot of work manually, traditionally, in the past, and by automating it away, we free up time that we can now focus and give back to our customers and our product features. So at Amazon, we had to do the same thing, and over the last 10 years or so, we switched more and more to automated processes, to CI/CD pipelines, continuous integration, continuous development. And as a result of this, by 2014, we were at a capacity of 50 million deployments per year. That's, again, a staggering number. We've also wanted to share how we do that, so we took our internal tooling that our teams had built for themselves and made that available to you so that you can begin automating your workflows in CI/CD. It's very dry up here, sorry. So when you put it all together, you get this state of flow. Do you have any surfers or skiers in the room? Couple? Okay. So you know what flow is, right? You're in that zone. It's just an amazing feeling. You don't have to really spend effort. Developers, you've seen them. Developers in the zone, when they're in flow, they could work 10 hours straight and not notice. And by implementing these practices, you can get the whole organization into a state of flow. And once you've had teams in a state of flow, they will never want to go back to anything else. Again, this is a superpower for your teams. So now we're going to take a deeper look at some of these practices that can help facilitate what I've discussed so far. How many of you have read this book? A handful. Okay, so Eric Ries wrote this book a couple of years ago, and He was interested in understanding how can you get to the value proposition faster. And his conclusion was that we have to work around hypotheses. Traditionally, product managers have an idea. Just do a little thought experiment here for a second. In your mind's eye, for a minute, drop down on any application you have, click on the File menu, and look at all the stuff that shows up. There's tons and tons of features in all applications that we all use. But how many of those features do you actually use? 10%? 20%? So why is all that stuff in those applications? They're there because product managers have been under pressure to create new features and new ideas, and so they cook up some idea, and they believe that somewhere somebody someday will use it, and maybe they will. But this approach is different. This is about having a hypothesis around what will be good, what adds value to a particular customer. That's the first hypothesis. And the second hypothesis is how can you actually then turn that value into a large customer base? How can I drive more and more users to consume that feature? And one way to test these hypotheses is this idea of a minimally viable product. So you've heard this term. A lot of organizations think of a MVP as the version 1 of a product, but that's not what it is. An MVP is really the idea that you want to test the unproven parts of your assumption in a product in a way that a consumer would actually use and respond to. So traditionally, and I've been doing this for 25 years or so, again, we have large project teams that we put together, and the project has a beginning, it has an end, it has a scope, it has a budget, it has a delivery date. And we focus on making sure that we hit that delivery date. It may not be the right thing for the customer, but we're going to hit that date, or we're going to stay within budget. And it's never both, right? It's always one or the other. And this older way of thinking, this aligns well with waterfall, is not really optimal anymore. There are reasons to do it. There are some use cases where you want to do a project-based methodology with waterfall. But more and more, the way to go and way to think about this is actually a product-centric view. And in a product-centric view, you actually think about the ownership of that product end to end. And you're continuously evolving it. There is no end date to a product view. A project has an end date. A product doesn't really have an end date unless you discontinue the product. And in a product view, you're working with your customers to constantly understand and build that roadmap out. Now, there's a third view that a colleague of mine, Mark Schwartz, has created and come up with, which is a business objective view. The idea here is instead of having a particular product, you have a business objective that aligns with your strategy. And you define a KPI, a key performance indicator, for that business objective. And then you put together your team to optimize that KPI. And that team has both technical as well as business people in it. And optimizing could be software development, it could be process improvement, it could be anything that drives that KPI forward. But different from a product view, when you've reached a threshold or a goal of that KPI, you might determine that any further effort, any further work towards that is actually not worth doing because you've already reached whatever that plateau is of that KPI. Yeah. How many of you have experienced the user acceptance test at the end of a long production cycle, development cycle, that was catastrophically horrible, and you couldn't you couldn't actually get it out the door, or you spent heroic hours at night with your team trying to get it done anyway, and took lots of shortcuts and incurred more technical debt? So I saw a couple of hands. I definitely, that was my experience for almost 20 years. Every time we released something, it worked fine, it works on my machine. We got it working okay. And then doing UAT at the very last minute, something horrible happened. We discovered something we missed, and there's no more time. And you still have to get it out to market because you promised the business and you promised your customers you're going to deliver something. So that's not a great approach. And still, for years, we persist in doing it this way. Instead, we should get to a point where we do continuous testing all the time. This includes, by the way, testing in production. In the old world, once it's in production, your feedback becomes the bugs that your customers find and log, and maybe some metrics. But in this world, you're continuously, constantly testing the success of that product. And by the way, it's not just the customer testing that you're doing, but you're also doing security testing continuously. Continuously checking that the policies are still maintained, that you don't have any 0 days, you don't have any problems. And then, at some point, you might actually take it to another level, like Netflix did, and use chaos engineering to test for your resiliency, right? Have you heard of chaos engineering? So the simian army, the chaos monkey, breaking things on purpose to see if your development teams can still build things that are resilient anyway. That has to happen in a continuous process. And by doing this, you're continuously also getting the feedback that goes back into the workflow, back into the agile process, back to the teams to continuously improve the product. So Amazon, we had the same challenge. And Amazon has many, many mechanisms that we think of as peculiar, that are peculiar to us. How we hire, how we interview, how we come up with new ideas, how we scale. We have a writing culture. So internally, we don't have any PowerPoint meetings ever, never, ever. It's always, everything's done in writing. And I'll talk more about that in just a second. And one way to do that, one mechanism we have is this working backwards methodology. And again, this goes in hand with product design and design thinking. And what we do is we'll write a paper from the customer's point of view, a narrative, a 6-pager. And then we'll write and the narrative, by the way, describes what we're trying to accomplish for the customer. AWS started as a 6-page narrative that Andy Jassy wrote. Our 125 plus services all started as a narrative that somebody had an idea and wrote down. And in that narrative, we also have a piece around frequently asked questions, but I'll get to that in a second. And then we have, as I mentioned earlier, this 2-pizza team construct where you own what you build. This is very powerful, owning what you build, because it means that when you deploy something into production and it breaks at 3 in the morning, for some reason it's always 2 or 3 in the morning, the operations team is not the one that's going to have to figure out how to fix it, because they don't know. And even today's world, the operations team has to dig around and look for the project members that built it originally to help fix it. In a product-centric world, the teams that built it are the ones that fix it when it breaks. So that's the ownership component here. And then we have architectural principles around service-oriented architectures, and I'll talk more about that in a second. When somebody has a new idea for a product feature and they've written their narrative internally, they write a press release. And the press release is basically a 1-page document that describes what the benefit of this product is for that customer. And along with that press, and by the way, this is looking forward into the future, right? We haven't done anything, we haven't built anything, nothing has happened. We've just written a document that says, this is what the press release will say 2 years from now for our customer. And then we'll write an FAQ that goes with it, frequently asked questions. And these frequently asked questions are questions that our customers might ask in the future, but also will include internal questions for the teams. And these should include all the really hard questions, the things that scare people. And we use this to communicate the idea because we've already answered those frequently asked questions. So we don't have to spend a lot of time in meetings debating it and talking about it. We just hand the paper out, you read it, and you have a good idea of what's happening. And if there's a question that's not in there, you add it, and somebody has to answer it. And then we also might have user interaction guides. We might have some low fidelity UI. And this should only be, as low fidelity as you can get away with. A sketch could be good enough. We don't have to spend a lot of time getting the perfect design at this phase, because the idea is simply to get started. We have an internal video where somebody asked Jeff Bezos whether it's mandatory to follow this working backwards process. And Jeff said, nope, it's not mandatory. It seems like a lot of work, but it's not mandatory. If you can develop a better way, and if you've followed the process many, 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 many times to find reasons why it doesn't work. And then he finished with this quote, and he emphasized that the process most often used in product development is actually the one that's backwards. So I already talked a little bit about two-pizza teams. Two-pizza teams are important because, like I said earlier, they're about minimizing communication. When you have 6 or 8 people sitting around the table and they share information, they all know the same thing. They all have the same baseline. If you try to ensure that 50 people on a team or 100 people on a team have the same knowledge, it requires overhead, it requires management, and you can't never get there. You ask people on the team, on a large team, the same question, you'll get different answers. If you ask a small team of 6 or 8 people, you'll get consistent answers. And bonus, you could have 8 people standing in front of a whiteboard, drawing and debating something, and having a really good discussion. You can't do that with 100 people or 50 people. They just won't fit. So these small teams are essential. The other thing that's important about these teams is, again, this is about reducing friction and reducing delays in shipping. And how do you do that? You put all the skills you need into that team. So this is essentially a cross-functional team that has everything they need in that team to move forward. They're not waiting on another team to deliver something. They're not waiting on another team to finish some process or project. They have the power internally to get everything done themselves. This allows these two-pizza teams to go incredibly fast. So Amazon started this way. We had a monolithic application. It was so large. It was so large that it took a whole day to compile. So if you've got a mistake, or you made a mistake, or you had to change something, you had to compile it again for another whole day. This was not speed-inducing. So we decided to break it apart and to rethink how we're going to work on this. I worked at a company called Experian in the US, in California. We had the same problem. We had monolithic applications, and there were so many hidden dependencies inside those monolithic applications that nobody knew exactly what would happen. If we made a change on one side, it would break something else on a different side. And it was really hard to predict, right? So we also decided then to follow this path of breaking up the monolith into microservices. When you break up the monolith into microservices, what you get, especially if you have two-pizza teams who can own each one of these microservices, what you get is the ability to move in parallel. You can have many, many teams working on discrete portions of functionality without breaking each other's code. So you can test it independently, you can develop it independently, you gain a lot of efficiency and speed. So today, if you're building new applications, I'm hoping you're already beginning to use microservices. Just quick sense in the room. Who's using microservices in their applications now? Okay, that's good. That's consistent with what I'm seeing in Europe as well. And of course, if you're using microservices architecture, you might be using containers, you might be using serverless. It's a good process and a good step forward. But don't forget, when you have a chance to pull out functionality from your monolith, chip away at it as you can. So this was in 2010, I believe. This is Amazon.com. So there are hundreds or thousands of microservices that make up the page. And the first couple of microservices were things like the buy button was a microservice, or calculating the tax was a microservice. And what we did is each service had a single purpose, as small as possible, as defined as possible. Each service had an API, and the only way to communicate with a service is through the API. There's no back channel communication or dependency that you might bake in. And it winds up being, an extremely decoupled architecture, which also gives resiliency, because if one of the components breaks, it doesn't take down the whole monolith. It just takes down that one microservice. So you can actually build resiliency in through this architecture. I have more to say about microservices, but I'm going to keep going. So when you look at the impact of cloud on product development, again, there are three features that I want to highlight. The first one is reducing the cost of failure. This allows you to experiment and try new things for very low investment up front. The second one is when new capabilities come online, you can implement them very quickly. Traditionally, when you wanted to implement a new capability, you had to provision servers, you had to install things, you had to have multiple copies maybe of whatever that service is. In this world, it's easy to incorporate new services as they come online. And then finally, when you're experimenting with your product ideas and you're building new things and they're successful, it's easy to scale very quickly and scale out large. So let's talk about some of the examples here. Jarrell is a company that builds systems for insurance and automotive. And they built an application called the MileUp app. The MileUp app was designed to help first responders after a crash by anticipating what the impact of that accident might be. And when they first started, they thought they would have 40,000 customers. But they were wildly successful, and they had multiple times more than those 40,000 customers. And so at one point, 3 weeks after launching, they found themselves in a situation where they had 22,000 concurrent requests. And they were able to sustain this growth and scale this growth so quickly because they had an event-driven architecture that was loosely coupled using microservices. Yeah, the other thing that's interesting about this is from the idea of this application into production, into final production, was 8 weeks. That's astonishing. That's something I could only dream of in the past. Mapbox. Mapbox creates mapping applications that you can embed in other applications. And they had two teams. One team that was working on optimizing the functionality and the performance characteristic of the app, and another team that was working on the underlying infrastructure. So you had two parallel teams, and so they could optimize, and the application team could focus entirely on the functionality without having to worry about the infrastructure, and the infrastructure team could provide value-added infrastructure in terms of logging, metrics, and security. And because they're using spot instances, they were able to drive their price down by 50% of what they had before. C-SPAN, this is maybe one of my favorite examples. So do I have any viewers of C-SPAN? Didn't think so. So if you don't know what C-SPAN is the world's most exciting television channel because they record Congress, right? They can and they record all the sessions in Congress. So it's actually a public service, right? And the idea is that they will index all of the video content of all the speeches that happen in Congress that they are allowed to film, and index them by who's speaking, who are the people on the video, what are the topics, maybe what time hacks, roughly what times people are talking about different topics as a service. They could only do 50% of the videos because it was so time consuming and intensive to do this manually. I mean, literally some poor soul had to watch all this video and annotate it. No offense to C-SPAN, it's very important. So they came here to reInvent last year, and we announced Amazon video recognition, right? And within 3 weeks after seeing the announcement that we had video recognition, they built an application that helped them index all of their content. And they were able to index every piece of video content they had in one day, matching it against 99,000 people in a database. And again, this is one of those things where because you can leverage existing services via an API call, the overhead of developing this application was actually really low, right? Because all you have to do is feed the video in and get the response back. So this is one of those things where by leveraging APIs that exist, services that we provide, you can dramatically accelerate product development. Edmunds. Any users of Edmunds? Any car shoppers? Okay. So I used to work at Edmunds a long time ago. And my colleague Phil Potlove, who works with us, came up with this example that they built. The idea was they were containerizing their applications, and they were running pretty hot. So a lot of their containers started failing randomly. And when they failed, it was a very bad customer experience, of course. So what they did is they took the log metrics that they could gather from those container services, and they fed them into an AI engine that built a model that can now predicts failure modes of the containers. And they wired it up to the management services in AWS. And when a container is imminently going to fail, the service gracefully shuts it down and spins up a new one, fully automated. So it resulted, of course, in great cost savings because 95% reduction in calls to their call center. That's awesome. But what's even more remarkable is the cloud engineering team that built this, none of them have any machine learning background whatsoever. They have zero knowledge of machine learning. So they used SageMaker to build the model, and they were able to do this on their own without any machine learning AI expertise. And they coined a phrase around this. They're calling this AI ops, which I think is kind of cool. And then there's many other examples. You look at Thomson Reuters. They process 4,000 requests per second for its product insight. FINRA, which has the responsibility of monitoring the stock trades in the US, processes half a trillion stock trades a day and monitors them for fraud or for any kind of irregularities. Expedia triggers 1.2 billion Lambda requests per month to manage their CI/CD platform. Again, all of these examples, I have no idea how you would do this in a traditional environment if you weren't in the cloud using these modern practices. I don't know how you would do it. I don't think it can be done. Clemson University. They had a requirement to do research in topic mapping, which is a component of natural language processing research. And they were able to spin up, in a matter of a couple of hours, 1.1 million concurrent virtual CPUs. Again, the scale of what you can do and how you can scale things out quickly and then turn it back down when you're done is staggering. Edco Genome needed a way to reduce costs on their genome analysis of the human genome. And by using field programmable gate arrays, the F1 series in the cloud, they were able to drive the cost down to $3 in compute time per genome. If you think about, in 2008, the cost of creating a genome, human genome, was $10 million. Now, 8 years later, just the CPU portion, there's other costs. It's $3. Okay. FICO had a problem, which was their daily utilization was between 10,000 and 300 million users, transactions. And so this variability was really hard. So when you in a traditional world, you have to provision for the worst case. So you have to provision for 300 million, even if only 10,000 events occur. So they were able to refactor their application using serverless, using Lambda. And now they don't care about this variability because they scale up and down as needed. And so they reduced their operational cost by 95%. 95%, that's, again, astonishing. And what I especially like is this ability to migrate things into Lambda very quickly. So they were able to rebuild their application in a matter of weeks using serverless. So I'm actually at the end of the presentation, and we're happy, and we can chat a little bit afterwards. But here's some books that I want to recommend and point you at. One of them is Ahead in the Cloud, which was published and authored by Stephen Orban, who used to head up the team that I'm on, which is the enterprise strategy team. And this book is a collection of user examples, customer examples of migrating into the cloud, of doing cloud adoption over the last 4 or 5 years. The second two are Mark Schwartz. Mark Schwartz was the CIO of US Immigration and Naturalization. And over a 7-year period, he took this US agency, bureaucratic organization, into the cloud using DevOps, using Agile, using design thinking. So if the federal government can do it, anybody can do it, right? And so these two books have some really, really good nuggets on thinking through these things. So the business value question is a question that starts with what is business value? How do you define it, right? And then the second one, as seated at the table, as CIO, he asked himself, if I'm empowering teams to be autonomous, two-pizza teams, what's the role of the CIO in that world? Is there a role? Right, so he started there. And he has a very interesting answer. And yes, there's still a need for a CIO. And then the last link here is our blog, the Enterprise Strategy blog, where there's 8 of us in our team. We write frequently, a couple of times a month, short articles, 1,000 words or so, on cloud adoption, on culture, on product, sort of all the themes that we've kind of touched upon lightly. And with that, I thank you for your attention. I thank you for coming this evening. And if you have any other questions, we could have sort of a after presentation chat. Thank you so much.